Welcome to the channel again, folks. I want us to look at calculus, interpretation of the graphs. But now, before that, let's do this question 10.1, which seems very much interesting. They say to us, given a function f of x, which is x squared minus 8. 10.1.1 says calculate f of minus 3. Now, interpreting this mathematically, they are actually saying to us, in this function, what is the value of y when x is equals to minus 3? Now, how do you do that? We are trying to find the value of y when x is minus 3 in the given function. Now look at what I did. First of all, I took the given function, f of x is equals to x squared minus 8. Then what I do is, as per their instruction, I replaced x by negative 3. Now, after doing that, I simplify the whole thing. Minus 3 squared is 9. 9 minus 8 is 1. Now that tells me that in this given function, when x is negative 3, the value of y is 1. We have answered the question. Moving on into the next question now. It says calculate f prime of negative 3. I want you to be very careful now here. They say to us calculate f prime of negative 3. What does that mean? It means that we go to the function, we differentiate it first. When we differentiate it, we are going to get the gradient function. What is the gradient function? The gradient function tells us the gradient everywhere in this function. Now, specifically here, they are asking the gradient at a point which is known as instantaneous gradient. Let's see how I did this one, folks. What I did is, the first thing, I determined the gradient function, which is the derivative of the function f with respect to x from the given function, which is x squared minus 8 is 2x. Now, from there, I did what they instructed me to do, determine f prime of minus 3. Now, once you put minus 3 there, where there's x, this becomes now the gradient. It is no longer the gradient function, but now it becomes the gradient. Therefore, the gradient at this point would be 2 multiplied by negative 3. You simplify that, the gradient is negative 6. We have answered that question. Let's move on to the next question now. Beautifully so. The next question says to us, determine the equation of the tangent to f of x, which is x squared minus 8 at a point x is equals to minus 3. Folks, remember that a tangent is now a line that touches this function in two arbitrarily close points. Now, let's see what I did here. One thing which I want to say before I go to my solution is, remember that what we ask you before might come back and help you. Never answer and forget about the answer. Answer and interpret the answer. Keep it in mind for the next coming questions. Now let's see what I did here in my solution. Number 1, I'm saying the equation of a tangent is defined as gradient multiplied by x plus the y-intercept. Now, in this case, remember I have determined the gradient of the tangent at a point x is equals to minus 3. Now it means where I see m, I must substitute minus 6, which is exactly what I did in my next step. The gradient at a point minus 3 is minus 6. Now y is equals to minus 6x plus c. Now, do you still remember that we did calculate the coordinates of that point where the gradient, where the tangent is touching our function, and the coordinates were minus 3 is to 1. Now, to determine the value of c, I use that point. Y is 1 and the value of x is minus 3. I substitute them, simplify. Now I know that the value of c is negative 17. I've got m, which is the gradient. I've got c, which is the y-intercept. Therefore, now I'm answering the question. The equation of a tangent at a point x is equals to minus 3 is y is equals to minus 6x minus 17. We really did great in that particular question. Now I want us to move on to the next question, where we are interpreting a cubic function. The statement says, the graph of a cubic function with equation f of x is x cubed minus 3x minus 2, and g of x, which is another function which is equals to 2x minus 2, is drawn. A and B are turning points of f. P is a point on G and Q is a point on F, such that PQ is perpendicular to the x-axis. Great stuff. Folks, keep in mind, we have the turning points and we are told that PQ is perpendicular to the x-axis. Now, let's attempt the questions and see how this information is going to help us to answer all the questions that they are asking us. Question number 1, they say to us, calculate the coordinates of A and B. Be very careful, the coordinates. Remember, they told us that A and B are turning points of a cubic function. Now, earlier on, we discussed the components of the cubic function, and we said for turning points of a cubic function, the derivative of the function with respect to x must be equals to 0. Now, this means that we should differentiate the given equation of the function, which is that, and equate it to 0 and solve for x. Let's go and do that. Now, step number 1, I have differentiated the function and the gradient function is 3x squared minus 3. Step number 2, I substitute 0, since we said that f prime x is equals to 0, next step, I divided by 3 throughout. Now I get the difference of 2 squares. Next step, I factorize difference of 2 squares. I get the factors x minus 1 multiplied by x plus 1, which is equals to 0. That says to me x is 1 and x is minus 1. Remember, we are looking for the coordinates of A and B. And we can see that at A, the value of x must be negative. At B, the value of x must be positive. Now, that means this is the value of x at B. This is the value of x at A. Now, to get the values of y, we need to substitute these values where into the original given function. Let's do that. When we substitute them, when we put x is minus 1 and simplify, we get 0. When we substitute x is equals to 1, we get minus 4. That means A is negative 1 is to 0 and B is 1 is to negative 4. We have answered the question perfectly, so got the easy 4 marks. Let's move on. If PQ is perpendicular to the x-axis, where are we now? PQ is perpendicular to the x-axis, meaning that at that point, the angle is 90 degrees. Calculate the maximum length of PQ. We are looking for the maximum length of that particular line. Friends, remember that the maximum length between two functions is always top function minus the bottom function. In this case, our top function is the straight line. The bottom function is the cubic function. For the maximum distance between them, we need to subtract the bottom from top. Now, let's move on beautifully and slowly so that everyone understands. The maximum length of PQ is therefore 2x minus 2, which is G, minus x cubed minus 3x minus 2, which is F. We simplify that, we get 2x minus 2 minus x cubed plus 3x plus 2. Further simplification where we add like terms, we get minus x cubed plus 5. Now remember the word maximum in calculus tells us to differentiate with respect to the variable what we have there. I differentiate that, it becomes minus 3x squared plus 5. Now, maximum length, the derivative of this function with respect to x must be equals to 0. That means I must equate this to 0. That is what I'm saying here. For maximum length, PQ prime, which is the derivative with respect to x, is 0. I'm talking about this now. We equate that to 0. Then we take 5 into the other side of the equation and we divide by minus 3. Now we get x squared, which is equals to 5 divided by 3. We take the square root of both sides to determine the values of x. Remember now, it would be plus or minus root of 5 divided by 3. Now, when we simplify that, we get negative 1,29, or x is approximately 1,29. Now, for maximum length, you need to substitute these two values at that particular equation. Remember, this was the equation that was defining the maximum length, which is minus x cubed plus 5x. Another thing that you can just quickly do is to trace the function which is produced by this. In this case, it would be this shape. Remember now, a is negative. When I trace that function, it would give me that. Now, I can see that here I've got local minimum, there I've got local maximum. To me, it tells me that this one would give me the maximum length, whilst this one would give me the minimum length. Now, for me to get maximum, I must substitute x into that function, which when I did, I got the length of PQ as 4,3 units. Beautifully answered that particular question. Now let's move on to the next question. Our next question says, determine the values of k for which f of x, which is equal to k, has only 2 real roots. Folks, what are they saying to us now here? They say to us, go to the function f of x, replace f of x by k. Now, solve for k and tell us where will this function have 2 real roots for k. Now, doing that, normally this is what I do. I take my ruler and check the number of roots. Can you see that when I'm here? This is my ruler now, which represents the x-axis. The function itself cuts the ruler only once. Now that tells me that at this particular value of k, the function will have 1 root. If I move my ruler down up to there, the x-axis, can you see that now? Right on top of the x-axis, I have 1, 2 roots. Remember, k is the value of y. At this point, I have 2 roots. Now, what I want to know is what must be the value of y. Can you see that this is the x-intercept? Can you see that that is also an x-intercept? And the value of y in both points is 0. Now I know that the value of k must be 0 for us to have how many roots? 2 roots. Now let's move the ruler below that point. I move it here. Can you see that when it is here, the graph is cutting the ruler in how many points? 1, 2, 3 points. That means I have got how many roots? 1, 2, 3 roots. But I'm only looking for only 2 roots. I ignore that. I move my ruler right up to there. Now, if it is there, can you see that it touches the ruler in 1, 2 points? Now, it means that at this point I have 2 roots. But now, what I'm looking for is the value of y at this point. Remember that the value of y there is -4. Now, this means that if I want 2 real roots for this function, the x-axis must be at a point where y is 0, and they should also be at a point where y is equals to -4. Now, let's go and represent that mathematically. So I hope that you still remember everything that I've said to you. When k is -4, that is when the x-axis are drawn at this point, we will have 2 real roots only. Or when k is 0, that is when the x-axis are drawn at that particular point and point there, we will have 2 real roots. Now the answer to that question is k must be equals to -4 or k must be equals to 0. Last question, 10.4. Determine the values of x for which f is concave up. Let's go to f again. Can you see that from here right up to there, f is concave down? From here right up to infinity, f is concave up. Now, they want to know for which values of x will this graph be concave up. Remember, once we talk concavity, it says to you, you must go and differentiate the function for the second time. Remember, you had f prime x. Now, you need to go and differentiate that function for the second time again. Your f prime x was 3x squared minus 3. Now we are going to differentiate this for the second time. When we do that, it would be 3x, which is equals to 0. We solve for x. X is equals to 0. Now we want to determine when will this function be concave up. Look at that. X is equals to 0 at that point, point C. Now, when is it concave up? Can you see that when you move to this side of the 0, when you move to this side of that point, your graph becomes concave down? But when you move to this side of this point, your graph becomes concave up. Now, what is happening to x as we move from here to that side? X is increasing. It is becoming bigger and bigger than 0. As we move to this side, x is becoming smaller and smaller to 0. Now, to answer that beautiful question, we will therefore say the function will be concave up when x is bigger than 0. That is beautifully answering the question. Folks, I just want to say to you, this is so easy if you practice and listen. And practicing and listening always makes us mathematical proficient. And for that matter, when you are mathematical proficient, you will see everything as very easy in mathematics. Now, when you see everything as easy in mathematics, that means you are procedural fluent. Thank you again for watching the video. Please subscribe, hit the notification button so that when we have something new, you are the first one to get it. And like our channel, and please folks, leave that positive comment if you have to. Share this channel with your friends so that we all do well in mathematics. Thank you very much. I love you all. I hope you also love mathematics.